In this simulation, we have a simple pendulum, and we can displace the simple pendulum from its equilibrium position. So I'm going to pull it back, and I can hit the start button. And as I start the simple pendulum in motion, a graph appears on the bottom. I'm going to reset it, and I'm going to displace it just a little bit further. So there we go, and start it. A graph appears on the bottom, and a red line appears that represents the total energy of the system. And the total energy of the system is just the addition of the potential plus the kinetic energy at any particular position on this motion. And I'm going to hit the pause button. So we notice that the total energy of the system always remains the same. It's always a constant value as the pendulum oscillates back and forth. And we also notice that when the potential energy is a maximum, so at any of these positions where the green line is at the highest point, that represents the potential energy being a maximum. It's displaced from the maximum value from that equilibrium hanging position. And when the potential energy is a maximum, the kinetic energy is a minimum, and specifically the kinetic energy is 0. So when the pendulum is displaced to its maximum position, that's the turnaround point. That's when it's released, and that's also where it turns around in its motion. And at the turnaround point, the velocity is 0, and therefore the kinetic energy is 0.